Please remember to subscribe and leave a comment down below. Your support helps us spread the magic. From the moment we take our first steps, we grapple with an invisible force, gravity. It keeps our feet planted firmly on the ground, dictates the arc of a thrown ball, and even governs the movement of planets in their celestial dance. Gravity, in its most basic sense, is the force of attraction between any two objects with mass. This seemingly simple concept underpins the very fabric of our universe, shaping everything from the smallest particles to the largest cosmic structures. But what if we could unlock the secrets of this fundamental force, bending it to our will? What if we could, in essence, master gravity? Imagine a world where the limitations imposed by gravity are mere suggestions, where the impossible becomes possible. This documentary embarks on a thrilling exploration of this tantalizing concept, delving into the profound implications of controlling gravity and its potential to reshape our world and propel us into a new era of human potential. Our journey begins by unraveling the enigma of gravity itself. We will delve into its fundamental principles, tracing its influence from the subatomic realm to the vast expanse of the cosmos. From the falling apple that sparked Newton's groundbreaking theories to the elegant equations of Einstein's general relativity, we'll trace humanity's evolving understanding of this pervasive force. We'll explore the milestones achieved and the mysteries that continue to captivate scientists today. Our exploration of gravity wouldn't be complete without acknowledging its profound influence on our home planet. Gravity's relentless pull shapes Earth's oceans, carves its mountains, and even influences the very air we breathe. Section 4. Beyond our atmosphere. But gravity's dominion extends far beyond Earth's atmosphere. It orchestrates the intricate dance of planets around the Sun, binds galaxies together in colossal clusters, and sculpts the large-scale structure of the universe itself. Understanding gravity's role in these cosmic ballets is crucial to comprehending the universe's grand design and our place within it. As we venture further from Earth, gravity's effects become increasingly apparent, particularly in the weightlessness experienced by astronauts. Section 5. A fundamental glue. This weightlessness, often described as a feeling of floating, highlights the absence of gravity's usual pull. It's a stark reminder that gravity, while invisible, is an ever-present force shaping our experiences. Despite its ubiquity, gravity remains one of the most elusive forces in the universe. Unlike electromagnetism, which can both attract and repel, gravity's influence is solely attractive, binding matter together with unwavering persistence. Section 6. The Cosmic Dance. This fundamental difference poses significant challenges in our quest to understand and potentially control gravity. It's a force that operates on scales both infinitesimally small and unimaginably vast, making it a formidable puzzle for physicists to solve. Yet, the potential rewards of unraveling gravity's secrets are immense. Imagine a world where we could manipulate gravity at will, reducing its pull to ease transportation, or amplify it to generate clean energy. The ability to control gravity could revolutionize industries, from construction and manufacturing to space travel and beyond. It could usher in an era of unprecedented technological advancement, transforming our world in ways we can only begin to imagine. While the prospect of controlling gravity might seem like the stuff of science fiction, scientists are actively exploring theoretical frameworks that could pave the way for such groundbreaking advancements. Concepts like anti-gravity, warp drives, and manipulating spacetime itself are no longer confined to the realm of imagination. They are active areas of research, fueled by the insatiable human desire to push the boundaries of what's possible. Our journey into the world of gravity is not merely a scientific exploration, it's a testament to human curiosity, ingenuity, and our relentless pursuit of knowledge. By daring to dream of controlling this fundamental force, we embark on a quest that could redefine our place in the cosmos. Join us as we delve into the fascinating world of gravity, exploring its past, present, and the extraordinary future that might await us if we can unlock its secrets. Our journey into the world of gravity begins not in the hallowed halls of modern science, but in the ancient world, where keen observers of the natural world first grappled with this fundamental force. Long before the advent of telescopes and particle accelerators, civilizations across the globe recognized gravity's influence, even if they couldn't yet explain its intricacies. From the ancient Egyptians, who built towering pyramids with astonishing precision, to the Greek philosophers who pondered the nature of the cosmos, humanity has long sought to understand the force that binds us to Earth. These early thinkers may not have had the tools of modern science at their disposal, but their observations and insights laid the groundwork for our current understanding of gravity. The ancient Greek philosopher Aristotle, for instance, developed a comprehensive model of the universe that placed Earth at its center. In this geocentric model, all celestial bodies, including the sun, moon, and stars, were thought to revolve around our planet in perfect circular orbits. Aristotle believed that each element had its natural place in the universe, with earth and water drawn towards the center, while air and fire sought the heavens. This concept of natural motion, driven by an object's composition, shaped Aristotle's view of gravity. He believed that heavier objects, composed primarily of earth and water, fell faster than lighter objects because they had a stronger inclination to reach their natural resting place at the center of the universe. While we now know that Aristotle's model of the universe was not entirely accurate, his ideas held sway for centuries, influencing scientific thought throughout the Middle Ages. It wasn't until the Renaissance, a period of immense intellectual and artistic flourishing in Europe, that Aristotle's geocentric model faced serious challenges. Pioneering astronomers such as Nicolaus Copernicus and Galileo Galilei dared to question the long-held belief that Earth was the center of the universe. Copernicus proposed a heliocentric model, placing the Sun at the center of the solar system, with Earth and the other planets orbiting around it. Galileo's observations with his newly invented telescope provided compelling evidence to support Copernicus's heliocentric model. He observed the phases of Venus, which could only be explained if Venus orbited the Sun, not Earth. Galileo's work, while met with resistance from the Catholic Church, helped to shift the scientific paradigm, paving the way for a new understanding of the cosmos and gravity's role within it. The stage was now set for one of the most profound scientific breakthroughs in history, Isaac Newton's law of universal gravitation. Legend has it that Newton, while sitting beneath an apple tree, was struck by a falling apple, an event that sparked his curiosity about the nature of gravity. Whether or not the apple story is apocryphal, Newton's genius lay in his ability to connect seemingly disparate phenomena and uncover the underlying principles governing the natural world. Newton realized that the same force that pulled the apple towards the Earth also held the moon in its orbit around our planet. He proposed that every object in the universe attracts every other object with a force that is proportional to the product of their masses, and inversely proportional to the square of the distance between them. Newton's law of gravitation provided a single unifying explanation for both celestial and terrestrial motion. It could explain why apples fall from trees, why the moon orbits the Earth, and why planets follow elliptical paths around the Sun. Newton's work not only advanced our understanding of gravity, but also laid the foundation for classical physics, which would dominate scientific thought for centuries to come. His laws of motion and gravitation allowed scientists to predict the movements of planets and comets with remarkable accuracy, further solidifying the power and elegance of his theories. The universe, once shrouded in mystery and superstition, was now becoming intelligible, its workings governed by predictable mathematical laws. However, as successful as Newton's theory of gravity was, it was not without its limitations. It could not, for example, fully explain certain subtle anomalies in the orbit of Mercury, the closest planet to the Sun. These anomalies hinted at a deeper, more nuanced understanding of gravity, one that would emerge in the early 20th century with the work of Albert Einstein. Einstein's theory of general relativity, published in 1915, revolutionized our understanding of gravity by proposing that it is not a force acting at a distance, as Newton had posited, but rather a curvature of space-time caused by the presence of mass and energy. Section 7. Gravity's Cosmic Dance, Explaining the Unexplained. This indentation represents the curvature of space-time caused by the bowling ball's mass. Now imagine rolling a marble across the trampoline. Its path will be deflected by the curvature created by the bowling ball. This, according to Einstein, is how gravity works. Objects with mass warp the fabric of space-time around them, and other objects, including light, follow curved paths through this warped space-time. Section 8. Beyond Einstein, the quest for a quantum theory of gravity. Despite its successes, general relativity is not the final word on gravity. One of the biggest challenges facing modern physics is to reconcile general relativity, which governs the universe on the largest scales, with quantum mechanics, which describes the bizarre behavior of particles at the subatomic level. These two pillars of modern physics seem to contradict each other in extreme environments, such as the Big Bang or black holes. The quest for a quantum theory of gravity, a theory that can unify general relativity and quantum mechanics, is one of the most active areas of research in physics today. Section 9. Unveiling the invisible dark matter and the gravitational puzzle. One of the most compelling pieces of evidence for physics beyond Einstein's theories comes from the study of galaxy rotation curves. Astronomers have observed that galaxies rotate much faster than they should according to the visible matter they contain. This implies the existence of a vast amount of invisible matter, dubbed dark matter, that interacts gravitationally with visible matter. Dark matter is thought to make up about 85% of the matter in the universe, but its nature remains one of the biggest mysteries in modern physics. Our journey through the history of gravity has taken us from the ancient world, where keen observers marveled at the falling apple and the cycles of the heavens, to the frontiers of modern physics, where scientists grapple with the mysteries of dark matter, black holes, and the very nature of space-time. Through centuries of inquiry, experimentation, and theoretical breakthroughs, humanity has steadily unraveled the secrets of this fundamental force. Yet, for all that we have learned, gravity remains one of the most enigmatic and awe-inspiring forces in the universe. It is the architect of cosmic structures, the choreographer of celestial dances, and the force that binds us to our planet. As we continue to explore the cosmos and delve deeper into the subatomic realm, we can be sure that gravity will continue to surprise us, challenge our assumptions, and inspire us to push the boundaries of human knowledge. As we've journeyed through the history of our understanding of gravity, we've seen how this fundamental force shapes the cosmos, from the smallest particles to the largest galaxies. Yet, despite our growing knowledge, gravity remains a formidable obstacle in our quest to explore the universe and unlock its secrets. Its relentless pull keeps us tethered to Earth, making space travel a costly and challenging endeavor. Every time we launch a rocket into space, we're engaged in a monumental battle against gravity's grip. Imagine, for instance, the daunting task of sending a manned mission to Mars, our planetary neighbor. The journey itself would take months, if not years, and would require a spacecraft large enough to sustain a crew for the duration of the mission. The spacecraft would need to be shielded from harmful radiation, equipped with life support systems, and capable of landing safely on the Martian surface and returning home. All of these factors add to the weight of the spacecraft, making the challenge of escaping Earth's gravity even more daunting. Section 3. Fueling our ambitions. The energy cost of defying gravity. The energy demands of space travel are not only a challenge for interplanetary missions, but also for more routine tasks, such as launching satellites into orbit. These satellites, essential for communication, navigation, and Earth observation, require vast amounts of fuel to reach their designated positions. This reliance on chemical rockets, while effective, is inherently inefficient and costly, limiting the number of launches we can conduct and the overall sustainability of space exploration. Furthermore, the energy required to overcome gravity's pull extends beyond space travel. Here on Earth, we grapple with gravity's influence every day, from transporting goods across vast distances to constructing towering buildings that can withstand its relentless pull. Finding more efficient ways to mitigate gravity's effects could have profound implications for transportation, construction, and energy consumption. Section 4. Material limits. Building for a gravity-defying future. Our current understanding of gravity also poses limitations on the materials we can use to build structures and machines. The weight of materials, dictated by gravity's pull, places constraints on the size and strength of bridges, skyscrapers, and even aircraft. Engineers must carefully consider the effects of gravity when designing structures, ensuring that they can withstand its relentless force over time. This limitation also extends to the development of new materials. Section 5. The information paradox, gravity, and the quantum realm. Beyond the challenges of space travel and material science, our current understanding of gravity faces a more fundamental limitation: its incompatibility with quantum mechanics. Quantum mechanics, the theory that governs the behavior of matter and energy at the atomic and subatomic levels, has been incredibly successful in explaining a wide range of phenomena, from the behavior of light to the properties of materials. However, when we try to apply quantum mechanics to gravity, we encounter profound theoretical difficulties. One of the most perplexing of these is the information paradox, which arises from the study of black holes. According to general relativity, black holes are regions of spacetime where gravity is so strong that nothing, not even light, can escape. Section 6. Unifying the forces, a grand challenge for physics. However, quantum mechanics suggests that information cannot be destroyed, leading to a fundamental conflict between these two pillars of modern physics. This incompatibility suggests that our current understanding of gravity is incomplete, and that a more fundamental theory, one that can unify gravity with quantum mechanics, is needed. Developing such a theory, often referred to as a theory of quantum gravity, is one of the grand challenges facing theoretical physics today. A successful theory of quantum gravity would not only resolve the information paradox and other theoretical inconsistencies, but could also shed light on some of the most profound mysteries of the universe, such as the nature of dark matter and dark energy, the origin of the universe, and the ultimate fate of black holes. Section 7. Beyond our reach. The limits of observation. Our attempts to understand gravity are further hampered by the limitations of our observational tools. While we've made incredible strides in developing telescopes and detectors capable of probing the farthest reaches of the cosmos, some phenomena, such as the interiors of black holes and the very first moments after the Big Bang, remain beyond our current observational capabilities. These limitations arise from the nature of gravity itself. Gravity is the weakest of the four fundamental forces, making it incredibly difficult to study, especially at the quantum level. Moreover, gravity's effects are often subtle and difficult to disentangle from other forces, requiring incredibly precise measurements and sophisticated experimental setups. Section 8. A universe of possibilities, embracing the unknown. Despite these limitations, our quest to understand gravity continues unabated. Scientists around the world are developing new theoretical frameworks, designing innovative experiments, and pushing the boundaries of technology in their pursuit of this elusive force. The challenges we face are not insurmountable, but rather stepping stones on our journey to unraveling one of the universe's most profound secrets. As we've seen, our current understanding of gravity, while impressive, is not without its limitations. Beyond conventional thinking, reimagining gravity. As we delve deeper into the realm of gravity, we find ourselves at the crossroads of current scientific understanding and the boundless possibilities that lie beyond. The limitations we've encountered, while significant, serve as a catalyst for pushing the boundaries of human ingenuity and exploring theoretical avenues that might seem like science fiction, but are grounded in the principles of physics. To truly master gravity, we must be willing to venture beyond conventional thinking and explore concepts that challenge our current understanding of the universe. One such avenue involves reimagining gravity itself. What if, instead of being an unyielding force that binds us to Earth, gravity could be manipulated, redirected, or even neutralized? This might seem like an impossible dream, but throughout history, what was once considered impossible has often become reality through scientific breakthroughs and technological innovation. Anti-gravity fact, fiction, or future possibility. The concept of anti-gravity, a force that counteracts gravity's pull, has captivated the imaginations of scientists and science fiction writers alike for decades. While anti-gravity remains firmly in the realm of speculation, some physicists believe that it might be possible to create conditions that mimic the effects of anti-gravity, such as using exotic forms of matter or manipulating electromagnetic fields. One promising area of research involves the study of negative mass, a hypothetical form of matter that would have gravitational properties opposite to those of ordinary matter. If negative mass could be created or harnessed, it could potentially be used to generate repulsive gravitational fields, effectively neutralizing the pull of gravity. Warping spacetime, the allure of warp drives. Another intriguing concept that has emerged from the realm of theoretical physics is the idea of warping spacetime. According to Einstein's theory of general relativity, spacetime is not a static backdrop, but a dynamic fabric that can be curved and warped by the presence of mass and energy. This warping of space-time is what we perceive as gravity. If we could somehow manipulate the curvature of space-time, we could potentially create shortcuts through the vast distances of space, allowing us to travel faster than the speed of light without violating any laws of physics. While warp drives remain highly speculative, the study of space-time warping has already yielded remarkable results. In 2015, scientists made the groundbreaking detection of gravitational waves, ripples in space-time caused by the acceleration of massive objects, such as black holes or neutron stars. These waves, predicted by Einstein's theory of general relativity nearly a century earlier, provide us with a new window into the universe, allowing us to study some of the most extreme and energetic events in the cosmos. But beyond their scientific significance, gravitational waves also hold the potential for technological advancements. Just as we have harnessed electromagnetic waves for communication and other technologies, some scientists believe that we might one day be able to manipulate gravitational waves, using them for communication, propulsion, or even energy generation. Speaking of energy generation, one of the most intriguing possibilities in our quest to master gravity lies in the study of black holes. These enigmatic objects, formed from the collapse of massive stars, possess gravitational pull so strong that nothing, not even light, can escape their grasp. But within their depths, black holes harbor unimaginable amounts of energy, locked away by the intense gravitational forces at play. Some physicists believe that it might be possible to tap into this vast reservoir of energy, perhaps by manipulating the accretion disks of matter swirling around black holes, or by harnessing the energy released during black hole mergers. As we explore these theoretical avenues, it becomes clear that our quest to master gravity is intricately linked to one of the most profound challenges in modern physics, the unification of gravity with quantum mechanics. These two pillars of our understanding of the universe, while incredibly successful in their respective domains, seem to clash at the most fundamental level. Developing a theory of quantum gravity, a theory that can reconcile these two seemingly incompatible frameworks, is crucial not only for understanding the nature of gravity, but also for unlocking the secrets of the universe's most extreme environments, such as the Big Bang and the interiors of black holes. A successful theory of quantum gravity could potentially revolutionize our understanding of physics and pave the way for technological advancements that are currently unimaginable. Section 7. A universe of possibilities, embracing the unknown. The journey into the realm of gravity control is, in many ways, a journey into the unknown. It requires us to challenge our assumptions, embrace new ideas, and venture beyond the boundaries of what we currently believe to be possible. While the challenges are daunting, the potential rewards are immense. Imagine a future where we can manipulate gravity to our advantage, constructing towering structures that seem to defy gravity's pull, building spacecraft capable of traversing the vast distances of space with ease, and harnessing the energy of black holes to power our civilization. Section 8. The ethical frontier, wielding the power of gravity. However, as with any transformative technology, the ability to control gravity comes with profound ethical considerations. The power to manipulate such a fundamental force could be used for both good and ill, and it is crucial that we carefully consider the potential consequences of our actions before embarking on this path. Who would have access to this technology, and how would we ensure that it is used responsibly? What safeguards would we need to put in place to prevent its misuse? Section 1. Engineering marvels, reshaping our world with gravity control. Imagine a world where the limitations imposed by gravity are mere suggestions, where the impossible becomes possible. This is the tantalizing prospect that gravity control offers, a prospect that extends far beyond the realm of science fiction and into the heart of what could be a technological revolution unlike any other. With the ability to manipulate this fundamental force, we could reshape our world, constructing awe-inspiring structures, revolutionizing transportation, and unlocking the cosmos in ways we can only begin to fathom. Perhaps the most immediate and tangible impact of gravity control would be felt in the field of engineering. The constraints of weight, stability, and the immense forces required to overcome gravity's pull have long dictated the limits of what we can build. But with the ability to manipulate gravity, these limitations could become relics of the past. Section 2. Defying gravity's grip structures that touch the sky. Skyscrapers could soar miles into the sky, their weight no longer a limiting factor. Bridges could span vast distances, their cables held aloft by carefully calibrated gravitational fields, eliminating the need for massive support structures. Underground cities could be constructed with ease, shielded from the elements, and offering new frontiers for urban planning. The very landscape of our cities, and indeed our planet, could be transformed, sculpted by our newfound mastery over gravity. Section 3. Transportation revolution, gliding through an era of effortless movement. Commuting could become a pleasure rather than a chore as we glide through the air, enjoying panoramic views and bypassing the congestion of traditional roadways. Goods and services could be transported with ease, reducing shipping costs and revolutionizing global trade. The environmental impact of transportation could be drastically reduced as we transition away from fossil fuel-dependent vehicles to gravity-powered systems. And then there's the dream of space travel, a dream that has captivated humanity for centuries. Section 4. Space elevators, a celestial highway to the stars. The concept of space elevators, long relegated to the realm of science fiction, could become a reality. These towering structures, anchored to Earth's surface and extending far into space, would act as celestial highways, allowing us to transport people and materials to and from orbit with ease. Space tourism could flourish, opening up the wonders of the cosmos to a wider audience. Scientific research could be conducted in space with greater ease and frequency, leading to new discoveries and advancements. Section 5. Resource extraction, tapping into the riches of the solar system. The implications of gravity control for space exploration are truly profound. With the ability to manipulate gravity, we could build spacecraft capable of traveling at incredible speeds, allowing us to explore our solar system and beyond with unprecedented freedom. Missions to Mars and the outer planets, once considered decades-long endeavors, could be completed in a fraction of the time, opening up new frontiers for scientific discovery and human exploration. Imagine sending probes to the icy moons of Jupiter and Saturn, searching for signs of life in their subsurface oceans. Section 6. Space travel transformed, unlocking the cosmos with gravity control. But perhaps the most tantalizing prospect of all is the possibility of interstellar travel, the ability to journey to other star systems and explore the countless worlds that may lie beyond our own. While the vast distances involved in interstellar travel present a formidable challenge, even with gravity control, some scientists believe that manipulating space-time itself might hold the key. Concepts like warp drives, while still highly speculative, are grounded in the principles of Einstein's theory of general relativity. If we could find a way to warp space-time around a spacecraft, creating a bubble of distorted space-time that allows for faster-than-light travel. Then the stars themselves could be within our reach. Section 7. Interstellar voyages, reaching for the stars with warp drive and beyond. Imagine embarking on a voyage to Proxima Centauri b, the closest known exoplanet to our solar system, a mere 4.24 light-years away. With a warp drive, such a journey, which would take tens of thousands of years with conventional technology, could potentially be completed within a human lifetime. The implications for our understanding of the universe and our place within it are nothing short of staggering. But interstellar travel, while a tantalizing dream, is but one facet of the transformative potential of gravity control. Section 8. Expanding our horizons, colonizing new worlds with gravity control. Imagine a future where humanity has expanded beyond Earth, establishing colonies on other planets and moons, creating a truly interplanetary civilization. Gravity control would be essential for such an endeavor, allowing us to terraform planets, create artificial gravity environments for human habitation, and facilitate the transportation of people and resources throughout the solar system. However, as we stand on the cusp of this gravity-defying future, it is crucial to remember that with great power comes great responsibility. The ability to manipulate gravity is a double-edged sword, one that could be used for both good and ill. Section 9. The gravity of our choices. Shaping the future with responsibility. The decisions we make today, the research we pursue, and the ethical frameworks we establish will determine the course of this gravity-defying future. Will we use this technology to create a more equitable and sustainable world? Or will we succumb to greed and short-sightedness, exacerbating existing inequalities and jeopardizing the future of our planet? The choice is ours. The power to master gravity, like any powerful technology, is a tool, and its impact on humanity will ultimately depend on how we choose to wield it. Section 10. A new era of human potential, embracing the gravity of our dreams. The journey into the realm of gravity control is not merely a scientific endeavor, but a profound reflection of the human spirit, our insatiable curiosity, our boundless ingenuity, and our unyielding desire to explore the unknown. It is a journey that challenges us to confront our limitations, embrace new possibilities, and imagine a future where the very laws of physics bend to our will. As we stand on the precipice of this gravity-defying future, let us proceed with caution, wisdom, and a deep sense of wonder. For the power to master gravity is not just about technological advancement, but about unlocking the full potential of the human spirit and shaping a future worthy of our wildest dreams. Our exploration of gravity's potential takes us now on a journey into the intricate workings of the human body, a realm where this fundamental force plays a surprisingly significant role. While we often take our physical abilities for granted, our bodies are constantly adapting to gravity's relentless pull, a delicate balance that impacts everything from our bone density to our cardiovascular health. Understanding this intricate relationship between gravity and human physiology is crucial as we explore the potential of gravity control to revolutionize healthcare and enhance our well-being. From the moment we take our first steps, gravity shapes our physical development. Our bones and muscles grow stronger in response to the constant resistance provided by Earth's gravitational pull, a process that continues throughout our lives. This constant interplay between gravity and our bodies highlights the profound influence this force exerts on our physical form and function. Imagine a world where the debilitating effects of aging, injury, or disease could be mitigated or even reversed using the power of gravity control. Conditions like osteoporosis, which weakens bones and increases the risk of fractures, could potentially be treated by creating localized gravitational fields that stimulate bone growth and density. Muscular dystrophy, a group of genetic diseases that cause progressive muscle weakness and degeneration, could potentially be countered by using gravity control to provide targeted resistance training, strengthening muscles, and improving mobility. For individuals with spinal cord injuries, gravity control could offer a glimmer of hope for regaining lost mobility. Exoskeletons, powered by controlled gravitational fields, could provide the support and assistance needed to stand, walk, and even climb stairs, restoring a degree of independence and freedom that was once thought impossible. But the potential benefits of gravity control extend far beyond addressing existing conditions. Imagine a world where athletes could train in controlled gravity environments, pushing their physical limits without the risk of injury. Astronauts, who often experience bone and muscle loss due to prolonged exposure to microgravity, could use gravity control to maintain their physical conditioning during long-duration space missions, ensuring their safe return to Earth. The elderly could maintain their mobility and independence well into their golden years, reducing their risk of falls and fractures. Section 4. Precision surgery, operating with the delicacy of a feather. Imagine a world where brain surgery, once considered incredibly risky, could be performed with the delicacy of a feather, minimizing the risk of complications and improving the chances of a full recovery. Or imagine a world where organ transplants, often hampered by the challenges of organ rejection and the need for lifelong immunosuppressant drugs, could be performed using organs grown in controlled gravity environments, perfectly matched to the recipient's body and eliminating the risk of rejection. The implications of gravity control for regenerative medicine are equally profound. Section 5. Cellular regeneration, unlocking the secrets of healing with gravity. Some scientists believe that gravity control could play a key role in overcoming these challenges. By manipulating the gravitational forces acting on stem cells, we might be able to influence their differentiation pathways, guiding them to develop into specific cell types needed for tissue repair. Imagine a world where damaged hearts could be regenerated, spinal cord injuries could be reversed, and neurodegenerative diseases like Parkinson's and Alzheimer's could be halted or even reversed. The ability to manipulate gravity could also transform rehabilitation, helping patients recover from injuries and surgeries more quickly and effectively. Section 6. Enhanced rehabilitation, redefining recovery with gravity control. Imagine a world where athletes could recover from injuries in record time, returning to peak performance stronger than ever before. Or imagine a world where the elderly, often frail and susceptible to falls, could regain their strength and balance, maintaining their independence and enjoying a higher quality of life. But perhaps the most profound implication of gravity control for human health lies in its potential to extend our lifespans. Section 7. Extending human lifespans, defying aging with gravity's help. However, what if we could slow down or even reverse these effects by manipulating the gravitational forces acting on our bodies? Some scientists believe that by creating controlled gravity environments, we might be able to reduce the wear and tear on our cells and tissues, effectively slowing down the aging process. Imagine a world where people could live healthy, active lives well into their hundreds, their bodies and minds as sharp as ever. Section 8. A new era of healthcare, embracing the promise of gravity medicine. The journey into the realm of gravity control is, in many ways, a journey into the heart of what it means to be human. It is a journey that challenges us to confront our limitations, embrace new possibilities, and imagine a future where the very forces that govern our universe can be harnessed to enhance our well-being, heal our bodies, and extend our time on this planet. As we stand on the cusp of this gravity-defying future, let us proceed with caution, wisdom, and a deep sense of wonder, for the power to master gravity is not just about technological advancement, but about unlocking the full potential of the human spirit and shaping a future worthy of our wildest dreams. Section 1. The weight of responsibility. Navigating the ethical landscape of gravity control. As we stand on the precipice of a future where gravity, once an unyielding force shaping our world, could be manipulated at will, we must confront a sobering reality. The power to reshape our universe comes with profound ethical considerations. The ability to control gravity is not merely a technological marvel. It's a mirror reflecting back our values, aspirations, and anxieties about the future we are creating. The ethical dilemmas posed by gravity control are not mere footnotes in a scientific triumph. They are central to our understanding of what it means to be human in a world where the impossible becomes possible. The very act of manipulating a fundamental force like gravity raises questions that strike at the heart of our relationship with the natural world. Have we, as a species, reached a point of technological sophistication where we can responsibly wield such power? Or are we tinkering with forces beyond our comprehension, risking consequences we cannot foresee? Section 2. A world without limits, redefining human potential and its implications. The allure of gravity control is undeniable. It whispers promises of overcoming physical limitations, soaring through the skies, and venturing beyond the confines of our planet. Yet, in our pursuit of these dreams, we must ask ourselves, what are the limits of human potential, and should there be any? The ability to enhance our physical capabilities, to defy aging and disease, to reshape our environment at will. These possibilities challenge our understanding of what it means to be human. Section 3. The equity equation. Ensuring equitable access to gravity-defying technologies. Ensuring equitable access to gravity-controlled technology is not merely a matter of social justice, it's a matter of safeguarding the future of humanity. If this technology is developed and controlled by a select few, it could be used to consolidate power, suppress dissent, and maintain existing hierarchies. Imagine a world where gravity control becomes a tool of oppression, used to enforce borders, control populations, and maintain an iron grip on power. Such a scenario underscores the need for international cooperation and transparency in the development and deployment of gravity-controlled technology, ensuring that it is used for the betterment of humanity and not as a weapon of control or domination. Section 4. Reshaping society, from social structures to economic paradigms. The ripple effects of gravity control extend far beyond our planet's surface. The ability to travel between Earth and space with ease would have profound implications for the geopolitical landscape. Who controls access to space? Who governs the resources of the solar system? Section 5. The geopolitical chessboard, gravity control, and the balance of power. The development of gravity control would not only reshape our world, but could also pose existential risks. The ability to manipulate such a fundamental force could be used to create weapons of unimaginable destructive power, potentially threatening the very existence of our species. The ethical implications of such technology are staggering, demanding a level of caution and foresight that has often eluded humanity in the past. However, alongside these risks lies the potential for unimaginable progress. Gravity control could be the key to solving some of humanity's most pressing challenges, from climate change to resource scarcity. Section 6. Existential risks and rewards, weighing the potential for progress and peril. As we navigate this uncharted territory, it is crucial to establish robust ethical frameworks to guide the development and deployment of gravity control technology. These frameworks must be grounded in principles of transparency, accountability, and the common good, ensuring that this technology is used responsibly and for the benefit of all humanity. International treaties and agreements will be essential to prevent an arms race in space, and to ensure that the resources of the solar system are not exploited for short-term gain, but are managed sustainably for the benefit of future generations. The development of gravity control technology is not merely a scientific endeavor, it's a profound test of our wisdom and maturity as a species. Section 7. Guardians of Gravity. Ethical frameworks for a gravity-defying future. The journey into a gravity-defying future is not one we undertake alone. It is a journey that will require collaboration, dialogue, and a shared commitment to using this transformative technology for the betterment of humanity. We must engage with experts from various fields: scientists, ethicists, policymakers, religious leaders, and citizens from all walks of life, to ensure that the development of gravity control is guided by wisdom, compassion, and a deep respect for the interconnectedness of all things. The future of gravity control is not predetermined. It is a future we are actively creating through our choices, our actions, and our willingness to engage in thoughtful dialogue about the ethical implications of this transformative technology. Section 8. A Shared Destiny. Navigating the future of gravity control together. The ethical and societal implications of mastering gravity are as vast and complex as the universe itself. We must approach this new frontier with a sense of humility, recognizing that we are not merely manipulating a force of nature, but shaping the very fabric of our existence. The future we create will be a reflection of the choices we make today, the values we prioritize, and the ethical frameworks we establish. Let us proceed with wisdom, compassion, and a shared commitment to harnessing this extraordinary power for the betterment of humanity and the preservation of our planet. Section 1. A Universe of Possibilities, reflecting on the gravity of our potential. As our exploration of gravity draws to a close, we find ourselves standing at the edge of a universe brimming with possibilities. A universe where the limitations imposed by this fundamental force may one day become mere echoes of a bygone era. The journey we've undertaken has taken us from the heart of atoms to the swirling depths of black holes, from the delicate balance of the human body to the grand stage of the cosmos, revealing the profound influence of gravity on every aspect of our existence. Yet, for all that we've learned, gravity remains a force shrouded in mystery, a force that continues to challenge our assumptions and ignite our imaginations with visions of what might be possible. Throughout this documentary, we've delved into the history of our understanding of gravity, tracing humanity's enduring fascination with this fundamental force from the ancient philosophers who gazed up at the stars to the modern scientists who probed the very fabric of space-time. We've explored the limitations gravity imposes on our current endeavors, from the challenges of space travel to the constraints on our ability to build towering structures and heal our bodies. But we've also witnessed the remarkable ingenuity and resilience of the human spirit, our unwavering determination to overcome these limitations, to find new ways to harness the power of gravity, and to unlock its secrets for the betterment of humanity. Section 2. The gravity of our choices, shaping a future worthy of our dreams. The potential applications of gravity control are as boundless as our imagination. We've envisioned a future where gravity-defying structures grace our cities, where transportation systems whisk us across continents and beyond with ease, where space travel becomes as commonplace as air travel is today. We've explored the potential of gravity control to revolutionize healthcare, healing injuries, reversing the effects of aging, and extending human lifespans. Yet alongside these tantalizing possibilities, we must acknowledge the profound ethical considerations that accompany the power to manipulate such a fundamental force. The ability to control gravity is not merely a technological marvel. It's a mirror reflecting back our values, our aspirations, and our anxieties about the future we are creating. Will we use this power wisely, ensuring that its benefits are shared equitably and that it serves to uplift all of humanity? Section 3. A new era of human endeavor, embracing the challenges and opportunities ahead. The journey into a gravity-defying future will be fraught with challenges, both technical and ethical. We will need to develop new technologies, push the boundaries of scientific understanding, and confront complex societal questions about the distribution of power, the nature of work, and the meaning of human existence in a world where the impossible becomes possible. But alongside these challenges lie opportunities for unprecedented progress, for solving some of humanity's most pressing problems, and for ushering in an era of peace, prosperity, and shared exploration. Imagine a world where gravity control helps us mitigate the effects of climate change, providing clean energy solutions, and enabling us to build sustainable cities that minimize our impact on the environment. Imagine a world where space exploration becomes a truly global endeavor, uniting nations in a shared pursuit of knowledge and inspiring generations to come with the wonders of the cosmos. Imagine a world where we use our understanding of gravity to enhance our health, extend our lifespans, and unlock the full potential of the human body and mind. Section 4. The unending quest, continuing our exploration of gravity and beyond. As we conclude our exploration of gravity, it's crucial to remember that this is not the end of the journey, but rather the beginning of a new chapter in our understanding of the universe and our place within it. The quest to unravel the mysteries of gravity is far from over. Scientists around the world continue to push the boundaries of knowledge, developing new theories, designing ever more sophisticated experiments, and searching for answers to some of the most fundamental questions about the nature of reality. What is the true nature of dark matter and dark energy? Those enigmatic entities that seem to defy our current understanding of gravity. Can we develop a unified theory of physics that seamlessly integrates gravity with the other fundamental forces? Is time travel possible? And if so, what are the implications for our understanding of causality and free will? Section 5. A final thought. The enduring allure of the unknown. The allure of the unknown has always been a driving force in human history, pushing us to explore uncharted territories, to challenge our assumptions, and to seek answers to questions that have haunted us for millennia. Gravity, with its profound influence on our lives and its enduring mysteries, embodies this allure like no other force in the universe. It is a force that binds us to our planet, shapes the cosmos around us, and yet continues to elude our full comprehension. As we move forward into a future where the impossible seems increasingly within reach, let us carry with us a sense of wonder, a thirst for knowledge, and a deep respect for the delicate balance of the universe we inhabit. For in the end, it is not the mastery of gravity itself that will define us, but how we choose to wield this power, how we shape our future, and what kind of universe we create for ourselves and for generations to come. The journey into the realm of gravity control is, above all, a journey of self-discovery. a journey that challenges us to confront our limitations, embrace our potential, and strive to become something greater than ourselves.